Hello again, everybody. Let me just get all of this still set up. As you can see, I'm running just a little bit late again today. Ended up having my hands full with something else before we got started here, so it should be ready in just a second. We have the chat up there now. The next stream is going to be Wednesday, 7/12. I think it's 7/12. Is that right? And we're still doing the same thing. Let me see here. Where did my other keyboard get to? So I have two keyboards here. I have the one that I normally use, which is a nice cherry blue switches, which are my favorite switches to type. Oh, there it is. They're definitely my favorite switches to type on. The downside is that they are quite loud, especially for doing things like streaming. So for the streams, I usually use a different keyboard, which has cherry browns on it. Actually, I think they might be Gatoron browns. But the end result is that it's a much smoother sounding keyboard. Like, you don't hear the loud click, click. Instead, it's like, it's still loud enough that it looks like it's triggering the threshold here. Let me see if I can fix that a little bit. So I believe it's noise gate. I'm not going to worry about it for now. But the end result is right that it's a much louder keyboard. It makes more noise, and unfortunately, it's not exactly what you want to hear on the stream. Oh, so I love my mechanical keyboards. At home, I have cherry blues, which I use for basically everything, and you're able to feel when you type, as opposed to when you're using a mechanical dome keyboard. So when I'm typing on a mechanical dome keyboard, like, I kind of feel a key press go in, but I can't really feel when it activates. Whereas with the mechanical keyboards, I can feel exactly when it activates, and I can tell, oh, I pressed the key and it worked. Or I did press the key and it didn't work. And it just feels better, in my opinion. Plus, they're getting so cheap that, it's hard to pass them up. Like, so personally, I buy a ton of my keyboards from Massdrop. Just because they're evil and sell basically all the things that I like to buy, and then send me an email about it every day about, ooh, do you want one of these? So let me throw this up here real quick. So I have... oh, I guess they don't have any of the ones that I have up right now. But yeah, like, it's $150 to get a kit to build one now. The loud keyboard you hear is one of these Varmio. It's actually a 60%. I mean, like, it's $60 for the low-end mechanical keyboards now. This one is using, like, actual cherry switches for $60. Like, they're cheap now and they're good. So I think they're well worth it. Like, with when they were $150, $200 for an entry-level keyboard, it was kind of questionable. But in the past couple of years now, there's been a whole bunch of competition, like straight out of China, essentially. There's a number of these small companies cropping up that the end result is, like, they're cheap, they're reasonably high quality, and they have all the options you want. Like, here I've got 1, 2, 3, 4, 5, and probably 8, 6, like 8, 9, 10 options in the Gatorons, depending on what all they are, plus different options of lighting. Like, it's not cheap, but it's much better than the, like, double or triple it that it used to be for them. So, in any case, I do recommend them. I like my keyboards a lot. I think between the ones I have at home and I've got two at work right now, so I definitely enjoy them quite a bit. But instead of just talking about keyboards all day, let's talk about what's actually interesting to most of us. Like, I find keyboards very interesting and could probably talk about them for quite a while, but unfortunately, it's not necessarily the most productive stuff to talk about. So, what we're probably all here for. There we go. Whoa, what is going on here? 8019. Oh. I bet you that... Let's kill all this stuff. So, if you follow me on Twitter, you would have, you saw that the, I got all the tests running. They were able to run, most of the time when I was gone. The problem is that, it turns out that if we get a crash, it doesn't pick up it doesn't remove its working directory. So, given all the internals of the OCaml compiler plus the stuff we're trying to compile, it turns out that's quite a bit of data. And, like, in this case, we still have some free space, but I restarted this maybe 15 minutes ago, and it ate up a couple gigs worth of data, so it has been eating up a lot of space. But the end result, of all of that is, while we have stuff to look at, find dot name core/star. We unfortunately only have 130 core files to look through, because I only have a 20 gig partition on this for storage. That ended up filling up pretty quickly when each failed case took up 70 to 100 megs. So I came back, it had been running for 3 or 4 days, and I had nothing to show for it, because it filled up the hard drive after like a day. But we have 130 to go through, and I think what we're going to do today, which will hopefully be interesting, is, if you remember back when we did the PDF Crack series, as well as a lot of the stuff with the NumPy series, we put together these really simple GDB scripts to just dump out PC. And it worked, and it got us what we needed, but it was really kind of simple. And, you know, I can't knock it too much if it works, but we can do a little bit better than that. Resized 80. Resize that one. Oh. Resize that one to 80. But yeah, even with the, like, it's rudimentary. Like, it works, but it's not ideal. We can do better than that. So I think what we're going to do today is we're going to build some stuff using the GDB Python bindings. So if you aren't aware of it, and actually let's come over here, we can go to the internet. There is actually quite a lot of stuff about using, and we need to move this window around a little bit. Oh, I always do that. That stays where it is. I want this to move for me. So there's quite a bit here about using, so you're able to use Python inside of GDB to do all sorts of stuff. You can do things like set up custom backtraces. Here's an example where, I'm not sure. This is not what I thought it was at all. This is not what I thought it was at all. I want this one? Yes. So, In GDB 7, support for extending GDB with Python was added. Awesome. Good stuff, right? Then result is that you're able to actually extend GDB with Python. Is this going to do what I want? It's still not... Here, this one might be... Okay, in any case, we're going to poke around with this. We're going to build some stuff in Python, which actually does some more complicated debugging for us. Because if you remember last week, we started getting these crashes. And we took a look at, I think, 2 or 3 of them. And the conclusion we came to was, I have no idea what we're triggering. Like, we have a handful of crashes which cause some sort of memory corruption. We don't know why. All I know is that for some reason, we're catching a page fault. I don't know how it was triggered. Like, it read some stuff out of memory and tried to dereference it, and we got a seg fault. That's what both the crashes we saw did. And that's not exactly enough to do anything useful with. Especially since, like, in order for this to be useful, in order for this to be a real security problem, we need to be able to trigger it in a controllable way. So even if I can write, you know, a simple loop that goes through and it actually triggers this, the tight loop portion of it. So actually, I guess, just to refresh everyone's memory, we can STL 150. I don't want any of this stuff. Well, here, this random website will get my click for this. So, according to Intel, short loops which use AH, BH, CH, DH registers may cause unpredictable system behavior. If you have a short loop of less than 64 instructions that uses the short registers as well as the corresponding wider registers, you may have unpredictable system behaviors that can only happen when both logical processors on the same physical processor are active. So that's the basic description of this thing. Which, I mean, it says a lot. The problem is that we put together, on the first of these streams, one of these tight loops that was messing with AH and RAX. And didn't do anything. Like, we weren't able to get any sort of corruption. Which leads me to believe that this line right here is critical. Under complex microarchitectural conditions, all the rest of this is true. So, if we want to be able to trigger this in any sort of useful way, we need to understand what those are. And at least my feeling on it is that we need to have the other thread running in a specific state. We can't just have one thread running in a specific state. We need a second one doing the same thing. Because if we don't, then we're not getting those complex conditions, and it all just works fine. So we need to find that. At least that's my guess right now. So yeah, what we need to do now is we have these core dumps, we have crashes, places where we got this unpredictable system behavior, but we don't have any way to... Where'd my mouse go? Oh, there we go. We don't have any good way to actually say, oh, this should be able to trigger it. We've got 130 cases of them, so we're going to dig in with Python. We're going to poke around a little bit, and we're going to see what we can come up with. I want to... Oh. Come on. One... Okay. Lit. Okay. That looks a little bit better. Then notes. We now have a notes file. Sorry, I'm still getting things a little bit set up here. So we have all this. Let's just take a look at these. The first thing we're going to do is we're going to make find dot dash name core. If I could type, it'd be a little bit easier. So yes, each of these is a unique PID, which is what I wanted to make sure here. So if we do a make dir cores, I should be able to do find dot dash name core star dash exec move. Come on, let's just CP it. CP it from there into cores. And apparently let this run for a while. I wasn't expecting this to be super fast command. What is going on? Oh, these core dumps are big. Wow, those are a lot bigger than I thought they were. There's 77 gigs of these. I don't think I can just do that. Hello, disconnected. I was copying them, right? Yeah. Oh, CD into cores. We're gonna remove all these. I guess we're gonna do what I originally was thinking about doing, which is we're gonna move them all. WC, we have 134 cores in here. That sounds like what we want to see. Well, 132? That sounds right. And up here we can see we can get rid of all of these other directories. So if I should be able to do arm-rf 7 star, 6 star, 5 star, 4 star, 3 star, 2 star. That explains why my system was becoming unresponsive. If I was running these tests on every core. And we still have all our core dumps. Awesome. Where was I? So we have that running. Well, it's not running, it's sitting there. We have a whole bunch of core dumps. Let's come in here. So we're going to do GDB. What is I'm looking for? I want GDB-C. GDB-C core slash core. There was a core, wasn't there? Yep. So, let me remember how I actually trigger this thing. So I can do Python, and there's this G. Look, it's Python 3. So yes, there's this GDB object, which gives us all of our stuff. And I should be able to come in here. And there should be a, what do I want to call this thing? Analysis.py. Import GDB. You know, we can just super simply right, it's Python 3 print dir GDB. So I want to do source analysis.py. And this is all the stuff in that. But ideally, oh, I should switch this over so you can actually see me poking around on the internet. So this is this sourceware documentation for this. And what are we doing here? The short version of this is this the one that I want, or is it the other one? I think I want the other one, don't I? No. So one of the things that comes up a lot when you're doing this that is actually super useful and probably is where you'll use the most is setting up these pretty printers, which is essentially so for certain objects. Trying to think of an example. So if you remember the NumPy series we did, we were able to cast a pointer to an object and print it out. And GDB spits out a pretty print version of it rather than just the pointer. And at least some of the time, that's a lot more useful to have. But those can be kind of complicated to write, and sometimes writing it in Python is just so very much easier. Yeah, there's this API for pretty printing values. So you can do things like display hints, set up children for it, a whole bunch of stuff you can do. It's definitely worth knowing how to do at least a little bit, because it's probably the most common thing you'd write in the GDB Python stuff. But, and I'm trying to remember how to do this, I want to read registers. Like we're going to start with that. I want to read a register. Your threads, recordings, no. Program spaces? Maybe architectures. No. Where is it? Maybe it's in basic Python? So I could do it using GDB execute, but that's pretty messy. Like you can use GDB execute to run a thing. But that's not what I want either. I can disassemble stuff. Again, not what I want. I want values. I'm sorry this is taking so long. I'm completely blanking on how to do this properly. Where? Okay, we're gonna do this other way. Which is, we're going back to this, and we're just gonna dig through this. So, GDB dot oh. Is this just the... No. This, I think, is what I wanted. No? To the internet. Oh, sorry. You guys can't see what I'm reading here. I can use PI. Really? Look at that. Thank you. And what do I do? Set pagination off? That's what I want. GDB. There we go. So if turning off pagination like that, that little more text display, press Q to quit thing, or enter to continue, with screen turned on, absolutely useless, and just makes it harder to read. So set pagination off just turns that off. And at least according to oh, I can do it that way, can't I? Huh. So gdb dot lookup symbol racks. Look up global symbol? Like, it has a value. It's not a good value, but it's a value. Oh, these are for real symbols. Okay, that's not quite what I want. Frames are... If I can get frame.pc, could work. Oh, I can do gdb dot, or pi, gdb dot frame dot read register racks. What? F is equal to gdb dot... Yeah, so I saw that is an option. But this frame is invalid. How do I get a frame? How about f is equal to gdb dot newest frame. There we go. So now I have a real thing. Yeah, there we go. So if I want value, I think? No. So racks is equal to f read register racks. Dir racks. I want racks dot string. Racks dot cast. Okay, we're gonna have to look this up real quick. So if we come back over here, I want the values. So racks dot const value. Seriously? I want... I just want to know what this is. Yeah, Pwn-debug is the other option here. So if you're not familiar with it, Pwn-debug has a whole bunch of stuff added to it to make things, especially for exploitation, easier. But I really wanted to make this super simple and just work with default GDB. Why is this not working? I have a value. I'm so confused right now. Rax.type. What kind of a type are you? I have to cast it? Rax cast to int. Oops. I need to actually get a type. So rax.type. What type are you? Rax.type dot name. Okay. Like you're already a type. Turns a new instance. If I init it that way. Okay, C is equal to gdb.value 1. Okay. C dot. So cast returns a new instance of casting it to the desired type. Dereference, we'll try and dereference it. Referenced value will return a value. Reference value, here, we'll switch this over so we can actually read along together. Const value returns GB value. That all returns it. I'm so confused. Is there really no way to find... I can mess with it, but I can't actually figure out what it is? So if I cast it, so I have a type. How do computers work? Oh, really? It's that easy? Of course it's that easy. Thank you very much, Disconnected. Apparently I just need to cast it to an int, because of course that's a thing. Okay. So, if we want to print out... so how did we get this in the first place? We want to get the newest frame. Right? So f is equal to gdb newest frame. So frame is gdb.newest frame. And then rip is frame dot register? Read register. read register rip. And we want to also get racks. I'll print this out. Rip is equal to %x /t. Racks is equal to %x, comma rip, comma racks. So now, of course it's going to do that. Source analysis.py. I should know much better than that. Percent of that. The cast is needed when I have a gdb.symbol instance. Oh, crap. Source analysis. Oh. Oops. That looks about right. We're printing out the hex bytes though, so 101 is 257. Which looks right. Except we want to do 08 and 08. Oops. That looks better. Let's get rid of this. Let's put space there. Actually, let's get rid of the comma altogether. That looks pretty presentable. So we have this. That just works. And I believe we should be able to do analysis.py. I want to quit then. Dash B. Dash batch. That looks pretty good. So this is now printing out just the stuff that we want. However, I also want to get we load this thing up. pi gdb.sys dir gdb.sys gdb.sys dot. That's the real sys. Dir gdb dot. Come on, we're gonna go back over to this documentation. I don't want to disassemble things. I want prog space, isn't that what I want? Prog space, don't I? Empty program space of the currently selected inferior. I want to get the core file that I'm using. I'm not quite sure what the best way to do that is. GDB. Oh, pagination's back on. Pagination. GDB dot. GDB. What's that? That looks like basically the exact same thing. Okay. I have lookups for stuff. GDB.obj files. GDB.obj file 0. Dir O. Yeah, I was thinking about doing that. What? Seriously? Doing a directory listing on an object file causes a core dump? Of course it does, because this is GDB. Did I get a core dump from that? I did not get a core dump from that. ulimit-c unlimited. Just because who doesn't want to get core dumps of their GDB? So I was thinking about doing the dumping out a bunch of instructions, but I'm not sure that's actually what I want to do. Because I think what I want to do is I want to take this analysis. We're going to run through all of these, and ideally get something usable out of it. So some basic analysis of here are all of the RIPs that we have. And to do that, think about what the best way to do this is. So one of the ways, well, let me rephrase that. Think about the lightest way to do this that does what I want. And the first thing that springs to mind is we're going to just set up a database for this. We're going to jam. So right now, what I want to get to start with is what is RIP? So what was the address that we crashed at? And what was RAX when we crashed? Because that's the thing we might be able to corrupt. The problem here, and what makes this difficult, and the reason why we're writing Python to do this, is because that's probably insufficient. I wish there was a good way to just do this. Let's take a look at this one real quick. So this is just one kind of selected at random. Cannot... Are you kidding me? So I'm trying to remember how to do this properly. Because what I want to do... Yeah, you know what? We're just going to do this way real quick. Import SQLite 3, SQLite 3.connect, quick analysis.db, and that's db is equal to that. No, I can't do this off the top of my head. Sorry, everybody, I do not use SQLite 3 frequently enough to actually know how to do this properly. So we have a cursor. DB. Yes, and that's why... No, it isn't a bad IP, which is why this is so dumb. Because it's actually this massive thing. It's just, for whatever reason, GDB did not grab the program. So, like, I can dump bytes out of this thing. I can dump bytes out of, I think this is the heap for it, like, but, it only captured the first, like, 100 pages or something, when this binary is massive, and we actually needed to grab that many bytes from it. We were using, last week, we were using Binary Ninja to actually look at these, because we could actually do that. Which I think is what we're going to end up doing eventually here, but to get things going quick and dirty, we're just going to dump some of this stuff real quick. So we have a database.execute, insert into crashes, I can do this properly. I know how to do this properly. Insert into crashes values, comma, comma. And I want to have rip and rax as ints. And then I finally want to do db.commit db.close. I also want to do SQLite 3. I want to do sudo apt-get install SQLite 3. So the problem with doing that is we're not going to just have a dictionary, because I don't know if I can easily get all of these at once, because I think it's going to be a unique script for each one. I'm not aware of a way to have this persist across all of them and open up each of the core files. So I'm going to have to do it this way. SQLite 3, what was it? Quick analysis.db. Create table crashes. It's an integer, right? Pretty sure it's an integer. Rip integer rax integer. Okay. So that should work. We do a source analysis.py. We crash. Okay. Line 15. It would help if I close my parens. A cursor has no... Oh. You know, I really should learn how databases actually work. Because, like, I know enough to do this stuff, but I don't know enough to actually do anything with them. I could have reopened the serialized file, added... Yeah. That's definitely a way to do it. This should work. So we have this. So I want to do... dash batch dash c core/core. That looks good. So find in cores dash name core/star dash exec this thing dash c, what we're going to run, like that. I'm really happy at the number of sigils we're seeing there. So this was just running through these real quick. That's interesting. We have core files that are not a core dump? How does that work? Huh. Apparently we have empty files that are supposed to be core dumps. That's definitely unfortunate. I'm not sure if that's a problem of mine or something else. But what I was saying was, this right here is super exciting. I believe we looked at one of these the other day, and we decided that it was a misaligned instruction, that we were supposed to be getting, like, we were jumping into the middle of an instruction somehow. And looking at the backtrace, we found a place where it looked like it might be calling a register value, which is super exciting if that's the case, and we can get it to do anything useful. But this now gives us all of our PCs. And I should be able to use my absolutely terrible database knowledge to do that. Sorry, I'm a little thrown off by the fact that we have a negative PC value here. That has to be because of, so we come back here. My gut feeling is that that is something in one of the libraries, right? It's got to do with casting, and because we cast it to a Python integer. Yeah, it's this thing. Wow, that is incredibly wrong. Huh. That's super intriguing. Like, that seems like a case of where we... I don't even know how we get that. Okay. Any case, we have these now. What do I want to do now? I want to see how many unique values there are. So, select count star from crashes. We have 130 crashes. SQL select unique count of values. Rip. Sorry, I know you can't see this. I am Googling because it's been oh so very, very long since I've used databases for anything other than I jam values into it and I see what happens. So there are 60 unique RIP values. I want the most common one. How do I do that? Which is interesting, right? It means over half of our PCs are non-unique. So if I do select star from values, order by rip. Oop, stop values. I want crashes. So we can see that, you know, this one occurred several times. That's a little interesting that, oh, those aren't quite the same. Never mind. Looks like a lot of them are happening a few times. That one happened a bunch. Nothing that, like, all over the place was happening all the time. Which is a little bit unfortunate. I was really hoping that if we did this analysis, it would turn out that, oh, look, it turns out that this PC right here, you just use it, and it turns out it just works. So this is the PC we're going to go look at. SSH, gotta start up my X server real quick. Come on, there we go. 192.168.0.19. I know you can't see this. We never set up the exporting, so that is there. Ta-da! We want to open the OCaml opt. And this is the most common PC. The downside of this keyboard that I'm using for the streaming stuff is that it is a, like, 40% keyboard, which means it's absolutely tiny. It doesn't have, like, home keys on it or anything. So, oh, I like that a lot. Select rip, count rip from values group by rip. Oh. Crashes. Ooh, you're getting all fancy on me. As C, group by rip, order by C. Ooh. Ah. Except I don't want rip, I want hex rip. Why did I expect anything differently? SQLite 3 print hexadecimal value. Why would I expect it to be anything but oh, I guess I can do that. There we go. That works. Why would I expect it to not give me the hexadecimal of when we converted that to a string? Hello, Clemza. So, back to where we were. This is the most common PC right here that we got a crash on. And the very first thing that jumps out to me of being interesting about this is this is a short loop. So if we remember from the description of the crash, the thread that uses AH and RAX has to be a short loop. And this is also a short loop. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So the looping condition here is 19 instructions. It's pretty short. Seems a little interesting, doesn't it? And I assume we're faulting on RDI here. And what's interesting here is that RDI comes from RAX. This is curious, to say the least. So we compare... No, what? What craziness is this? We're going to... Seriously? So we look at we move RAX into RDI. We then see if it's 1. If it's 1, we're going to return. Otherwise, we'll come through here, and we're going to dereference it. So that's bizarre. Like, there's an error case of 1 to bail out of this function. Kind of wacky. So to answer your question, Clemza, so the setup I'm currently using is stock Ubuntu. It's currently 1604. This display right here is just screen. I'm actually using the Bash on Ubuntu on Windows stuff to have native SSH from a Windows 10 computer, and then I'm SSHing into a Ubuntu machine. In this case, I'm SSHing into a physical Ubuntu machine. It's the laptop I play CTF from. However, I also, for most of the streams, have been using a Hyper-V VM that's running, I believe, the latest release of Ubuntu. So that'd be 1704 right now. And it's just stock, and that's it. And yeah, this is just screen that's displaying this. So, back to this. So, yes, it looks like it's going through a linked list. What's really interesting, though, is that the termination condition is 1 and not 0. Like, that seems kind of wacky to me. But that's fine. Okay, so that was the most common one. The next most common one is Ooh, it's in Mark Slice. Ooh, interesting. Ooh, that's actually really interesting. So if we look at this one, right? We calculate R12 directly from RAX. So the guess here, right, is that RAX is somehow getting corrupted when it uses the AH register in the other thread. This seems promising. So where are we? I want to come over here, select star from crashes where rip is equal to that. Oh, I'm sorry, you guys can't see that. That's not quite what I was hoping for. I want printf %x 08x comma rex. So one of the things that was proposed was that the other thread is doing an AND of RAX with a thing. That doesn't jump out to me as being an AND of RAX. Like, those are just clearly wrong. Well, I don't know if they're wrong or not. So the idea here is it's an LEA of R12, or it's an LEA. Here, I can actually just show this. So we do an LEA R12 R15 plus RAX. And this RAX does look pretty clearly wrong, right? There's no way that we should have both, like, this stuff and that stuff that's calculating to some sort of a pointer. Especially since R15? Why is this computer working so hard? Oh, it's because I'm SSHing it. Yeah, I'm doing SSH forwarding. So R15 is the current value. And it looks like RAX is getting like an offset from it. So this is probably like R15 is the start of some heap allocation, and then RAX the length of it. That would make sense. But there's no reason we should have some of these lengths that are just like that big. Like, that's clearly very, very wrong. But that still doesn't jump out to me as being the problem. Like, that, it's all well and good that that's wrong. It's very clearly wrong. So one thing that's very important here, though, is that this is not a short loop. Looking at this thing, this loop is massive. I'm not even sure there's a path through here that, well, okay, so there is a path here that looks like it'd be a short loop, right? So this, oh no, that goes down. Oh no! Oh man, it is struggling with this function. Double click on this, right? That's interesting. No, it's not. So follow this. We then add 1 to RBX and continue, right? And then we loop right back around. So I mean, I guess I could see that being a short loop, but only if it was BPL. But the low byte in BP? RBP? Are they really using RBP as a general purpose register? These are bad people. And by these people, I mean the GCC compiler optimization people. Not that they're actually bad people, I'm just saying RBP as a general purpose register is a little annoying to read. So that seems fine, right? There is a path through there that's going to be a short loop, which is interesting. What about the next most common one? So this one came up 12 times. This one was 6 times. This is not a short loop. This can't be a short loop because we're outside of the loop. Maybe like if we go out of function or something, it could be, but this very certainly cannot be a short loop. At least not inside of the same function. Which is interesting. Also can't return, can it? So if we come in here, we go into call GC, and then I guess whatever camel apply for does. So I guess it could eventually return. So that kind of breaks that theory. If the theory was we have to be in a short loop too, it doesn't entirely break it, right? Because RDI is being RCX is what we're segfaulting on, because we're on that 538 instruction, which is one of the arguments to this function, and came from REX. What am I doing here? I want to do this 474538. That's certainly interesting. The first thing that we're running into here that I want to go fix real quick is we're going to get rid of our analysis database. Create table crashes with values. I hope I got the syntax right for this. No, I do not. I want rip integer. What am I doing? I'm being completely dumb about this. Oh, my poor machine. Why are you so unhappy? Please don't die. You shouldn't be running anything that is very CPU intensive. Oh. No. Okay. So vim schema dot SQL create create table crashes. We want rip integer set auto indent rax integer. So we want BP, RBX, RCX, RDX. RDI and RSI. And then I also want to get, might as well get everything, right? RSP, RBP, and then this is going to be R8. 9, 10, 11, 12, 13, 14, 15. We're just going to rerun all this. We're going to grab all the values because I'm bad at this. 11, 12, 13, 14, 15. So if I was doing things properly here, for anybody watching this, I would be using the auto increment stuff from Vim, but I can't do that because I am is it .load? Read? There we go. What? No. There we go. So I did that. And then 5, where is... There we are. So we got Rax, our BX, CX, DX, DI, SI, SP, BP, 8, 9, 10, 11, 12, 13, 14, 15. That is many, 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 many. Actually, you know what? Let's get rid of these. And we want to actually do, we're going to cast all the rest of these directly to integers, because there's an argument to be made that we should have been doing that to begin with, but BX, so my thought at least was that if we don't cast these to integers, we might want to use them later when we do more analysis. But we're fixing it now. BX, CX, DX, DI, SI, SP, BP, 8, 9, 10, 11, 12, 13, 14, 15. Rax, RBX, Rax, RCX, Rax, RDX, Rax, RDI, RSI, RSP, I'm sure there's a slightly easier way of doing this than what I'm doing right now. At least right now I can't think what it is, so this works. Up. Okay, so we did that. Except we need BX, CX. What am I doing? Yank to left. So BX, CX, DX, DI, SI, SP, BP, 8, 9, 10, 11, 12, 13, 14, 15. And then we have to add these in. RBX, RCX, RDX, oh no. RDX, RDI, RSI, RSP, RBP, R8, R9, R10, R11, R12, R13, R14, and R15. So, we're now rerunning all that analysis. It's really great how fast this is. Like, compared to what we were doing before, like, this is definitely significantly faster. We come in here, we'll do this. We have all those values recorded for us. So, we said that we want to see what... So, let's start with when we have this 474534. Go away. Select printf. We're going to print out Um, Rax is equal to %08x. I also want RCX, because that's what we're actually going to read from. Oh, that's interesting. No. RAX is kind of useless. RCX is %08x. Do I care about anything else here? Take a look at what RDX is. And we want RCX and RDX from crashes where RIP is equal to OX 474538. My connection is unstable here. It's interesting. I actually haven't gotten a message about any filtered comments, which I thought I usually got. So I think at least part of the problem here is... Let me check here. Where is it? Yeah, it's dumb. There's... So one of the... Oh, you're not able to see it even. One of the options you can select is normal or low latency for a stream optimization, and I always forget to switch it to low latency. I need to make sure to add that to what I do next time, because it's for best quality, which apparently is not great quality for most people. But here's where we're crashing. And if we take a look at what the RIP is for all of these. So we're reading from RCX, which is very clearly wrong, but it's the same value in each of these, which is very interesting. It's fascinating that a image link did not cause problems, but other stuff does. Oh wow. Oh, that would have been so much easier. That's right. That totally would have been easier to do. Huh. Interesting. Yeah, I totally didn't even think about doing it that way. So you have a array of registers. You're then going to create a dictionary out of it with the register name and reading it out. Yeah, that's totally the easier way to do it. It's weird that, I thought YouTube would usually tell me if it tried to reduce spam, but I guess not. Oh, and of course, I'm looking at this and other people can't see it, but... In any case, looking at this crash, it's very interesting to me that all of the RCX crashes are the same thing. Because it's not quite what I would expect to see. I kind of would expect that these be different. What was this function? So, what is the question there, Deep Deep? If it takes 5 seconds to load, I would expect to have slow results. Well, I'm not sure what fuzzing in a loop is. I want... No, I don't want that. Thought I could... Don't remember what this is called. Oh, just start typing. Sweep slice? Yeah, sweep slice I think is the one that they suspected was causing problems for them. And if we go into sweep slice, there should be in here some use of AH. Yeah, we and it with FC. 3 execs a second? Wow, that's some slow fuzzing. Hmm. I mean, I guess you can't say anything. Like, if it finds crashes, it finds crashes. You shouldn't optimize stuff until you know that you found the bottleneck. It makes a lot more sense to get something up and running and then deal with it. So, repeatedly send file data to standard in until end of file, and handle that file with the function you want to fuzz. That makes sense. Like that. Seems like a reasonable approach. So looking at this function, we're basically walking this thing, right? What if we're wrong about the assumption here? So we use AH here, and then we come down here, we test RBP, because RBP is just a general purpose register, and we loop back around. We then read from we read RDI in, we're gonna come back in here. So what is it that you're trying to do, Deep? Like, what is the issue? It sounds like you're getting a reasonable number of test cases. It's just that AFL is misreporting them because you've modified your program to handle multiple inputs at a time. So we read from that. We're going to read from RDI into REX. We then move it. We shift it. We put that into RBP. We then calculate an address based off of that. Well, we don't. It's not necessarily an address. No, it's an offset. We write that into there. So RDI is a size. So we read that out. That looks like a size. We shift right by 10. We then multiply by 8 and add 8. Okay. We then move REX into that. This code kind of hurts my head. Like, what they're trying to do is a little weird here to me. But we and it, and then we immediately write it. So what if the assumption here is wrong? Right? So one thing that I hadn't considered is the what if the reason we were failing before isn't because our loop isn't doing something useful? It's because we're not, like, what if it is actually all in this loop? And I'm trying to think of what a way to test that is. We end up getting a segfault. Hmm. Oh, you're trying to fuzz antivirus stuff? I would kind of expect that to be really slow because of how they're doing processing. And unfortunately, I'm really not that much of a fan of straight black box fuzzing. I think one of the, and now we're going to go off on a tangent for a little bit. One of the best pieces of advice that I got for fuzzing was that when you're doing fuzzing, one of the assumptions that I always used to make when I for the longest time I knew that fuzzing works, and I know that it you can find bugs with it. It's great and all, but I'd never had good success with anything other than I literally shove random bytes into the thing and see if it crashes. If that didn't work, my fuzzing never worked. But I was talking to Gamozo recently being 6 months ago, about his techniques for fuzzing. So in that discussion, I realized that I was doing fuzzing all wrong. That I wanted to do just black box fuzzing. Here's a binary. I want to crash. And what really changed my mind about fuzzing was that fuzzing is to explore some space of a theory. So I have a theory that an input to this program will cause a crash. And if all I'm doing is I read in a file, I mutate it somehow, and see if it crashes, that's the theory I'm testing. But it's a lot more interesting when you have a more intelligent theory. Instead of doing, I'm going to read in a random file and see if it crashes, I want to create valid Python that uses objects in a library and see if that causes a crash. But you can get even more specific than that. So I want to set up a specific state, and can I get this state to something else and try to explore that state? Like the difference in thought between I just want to see if there's a crash, or I want to see if this set of things, I want to explore the state in this set of things, really changed my approach. I think it ends up working a lot better. Which is a long way of saying that pure black box fuzzing might not be the best approach. That looking into it first and knowing what you're looking for is a good idea. A good example is, so if you're looking at an antivirus program, the way that I would start is actually crack it open in IDA or Binary Ninja and say, here are the file types that it can have. And I would start by doing some quick analysis of it, like which processing methods are complicated at all, and eliminate all of those. And push down a little bit like that. That way, each of your fuzz cases, even if they're super slow, like even if it takes you a second to fuzz case, then having each of them be more valuable is going to be important. And the problem is if you're doing just pure black box fuzzing, you can't do that. I can't say, oh, give me, I can't know what is useful if I don't know what it's doing. And that can be a very, very quick analysis even. I just want to run through, here are all the places it opens a file, so here's how we're going to trigger this, and we're going to, do some basic work to get us down the first handful of branches. And just starting with that as your corpus ends up making using AF a lot better. And I guess you can say in theory that that's black box fuzzing, but at least in my opinion, it's very much a gray box fuzzing at best, because it took a lot of knowledge about how the thing works to get you to where you started. That's a long way of saying slow test cases might not be the end of the world, and unfortunately, I'm not an expert at AFL. Like, I know it well enough to run it, and sometimes it crashes. But especially given the PDF crack series, like, I'm definitely far from being an expert in how to make it work well. So, with all of that tangent, going back over to this, one thing I hadn't considered here is what if we're corrupting RAX and not the other thread? And I'm not sure of a great way to test that. So, what if we are writing into, when we write this into RDI, the problem that we're running into, because we're kind of consistently seeing kind of a pattern. Where is, so I want to, I'm going to have to scroll up here to get the right code for it. I want this. I know you can't see this right now. No. From all the way down. So yeah, I actually haven't read that post yet. Interesting post on fuzzing based on stack depth malloc stuff. The internet. It's not how long you let it run, it's how you wiggle your fuzzer. That definitely sounds like a Sun Tzu quote. That is fascinating. Yeah, one of the things that I don't think that I've done enough analysis into is there's a lot of really interesting things people have done with LLVM passes to get different stuff. One of the more interesting ones that I've seen is using an LLVM de-optimization pass to make fuzzing faster. Basically, the way AFL works, right, is it flips stuff in a file and checks to see if we got down a different branch. But if you do something like a stir compare of a magic for a file, I'm comparing 4 bytes at a time, AFL will almost never find that because it would have to get all 4 bytes right at the same time. So what this person had done was they wrote a LLVM pass to de-optimize this compare. So instead of being nicely optimized to do all 4 bytes at the same time, it would go bit by bit and compare each bit in like a nested if statement. The end result is they ran that against something pretty simple. I don't remember what the original post was for it, but they ended up finding stuff much faster because AFL actually worked on it now, as opposed to just completely falling over. And a lot of these LLVM test case stuff, it's something that I really would like to know more about and have just never actually done. So I have not read this. I am definitely going to take a look at it after the stream now. So, with that said, let's take a look at a couple more of these test cases, because we've got probably about 20 more minutes before I'm going to call it an evening. So this was where I can set a bookmark, can't I? Can I set a bookmark? Is that a thing, or is that a plugin? That is definitely a plugin. So before I go anywhere, I want 65 F3 F3. That's where we suspect our corruption is occurring. This is the most common crash that we get. Oh. Sorry, that is the most common crash when we process things wrong. Printf %08x that. This is it when I actually convert text properly. And I went graph view because graphs are so much prettier. So 7, 9. Okay. So looking at this pattern, we're reading from it. We're then reading from 8 bytes after, like we're reading from RDI. We're then reading from RDI plus 8. And using that as the next element. So this is the most common crash that we got. Oops. Let's switch over here real quick. So select star from, no, we're gonna do this right. Printf %x %08x RDI from crashes where rip is equal to OX61B279. So these are the values that we're trying to read from when we crash. And look at these, a couple things kind of jump out to me at first. One is that there are 2 cases where we are reading from 44230, which seems a little odd. And other than that, it seems a little weird. Like these are very, very, very clearly not even close to being pointers. Let's keep thinking about this. So we read from RDI, or tried to read from RDI, and RDI came from the next element in this linked list. If we go back to where we were before, so go 6, 5, 4, or F3, F3. We just wrote to RDI. And RAX should look kind of like a size. What if this is all related? So this is writing to RDI using RAX. The next most common one well, I guess that kind of breaks that theory. But this is using RAX and R15. Oh, I'm sorry, you can't see this. So the next most common one is 65F67C. And we want %08x. We want R15, RAX, and R12. %08x. Okay. So those are the values in the crashes. And we said that R12 Whoa. What? R15, RAX, and R12, where RIP is 65 F67C. That's impossible. Percent 08x. I want R15 plus RAX times 8. Okay. Can I just not do math? That's odd, but I'll buy that. So the train of thought here was that there is no way that this times 8 plus that somehow gives us the low, like, is page aligned. What? I guess it is. That's odd. I mean, I guess that's a thing. It is odd that those are all crashing, though. Wait a minute. Those look like those could be valid addresses. But maybe in the wrong process. I want to find 65F67C. Oh, nope, don't select anything. We're going to run backwards. 65F67C. And that should be the core file. So come over here, gdb-c cores core.23772. So this caused a seg fault. And I want to do gdb-c core/core dot 23773. So these two should be sharing a core. Nope, that's unfortunate. Wait, what? So what I was kind of hoping for here was that R12 would look like an address from the other process. But R12 looks like we just fell off the page. Like, that looks like it's just the end of one of, like, we just ran off the end of the page somehow. Which is not at all what we're looking for. Getting excited for nothing. Mm, okay. Well, this doesn't seem like it's going anywhere useful. So, we're going to edit our test harness a little bit. Basically what we're going to do, rm star slash test star. And so what this is doing is this is removing all the extra junk that we don't really care about. Every time we run one of these tests, we want to get rid of a whole bunch of the test harness stuff we don't really care about. At least that's the purpose of this. And so I think at this point we're gonna end the Intel stuff, call it a day on that. This test harness is gonna run. We're gonna get hopefully many hundreds more test cases out of this. Like my goal here is I'm gonna let this run till Wednesday. Hopefully I'll be able to get a whole bunch of test cases out of this, and we can analyze those on Wednesday and maybe get a little bit more out of it. Because 130 is not very many to make any sort of tendencies out of. So let's get this started real quick. That is up and running. So, in addition to that, for those of you who enjoyed the CTFs, this weekend is probably going to be one of the better weekends for CTF in a while. Because there are, in fact, 2 CTFs going on this weekend. There is Meepone, which is run by... so I don't actually know who the Meepone group are. They say they're out of Vietnam. That's about all that I really know about them. They, at least as this group, do play in a number of events. In particular, they seem to be big in Vietnam because they're actually playing in a bunch of these white hat contests, which are also Vietnamese contests, and doing quite well at them. So, like, they're a CTF team, they do stuff, so it should be at least interesting. Like, they do really well in the Vietnamese competitions. They don't seem to do a whole bunch in some of the, I guess for them, foreign competitions. So this starts this Thursday, at least, so Thursday Eastern time. So for me, this starts at 8 p.m. on Thursday. So whatever 1 hour after the stream would normally start. And that starts on Thursday and runs through Sunday. So it's actually like it's a 48-hour event. For me, it goes from Thursday at 8 p.m. to Saturday at 8 p.m., I think. And then there's also CTF Zone, which, for one, is hilarious that it is a, like, I think somebody said it was a Russian-based CTF that is totally making fun of presidential election manipulation. So let's hear it for topological, or not topological. That's heights of things. Whatever that word is. Relevant humor. But this is the qualifier for a in-person competition at Zero Nights. I think somebody said that they are... Yeah, they're going to cover travel and accommodation plus visa support for the 10 qualified teams of up to 5 people. And then for me, this runs from, I believe, Saturday morning through like 5 p.m. Sunday afternoon. But the end result is I'm going to be able to play CTF continuously from 8 p.m. on Thursday through 5 p.m. on Sunday in 2 different events, both of which seem interesting. I know several of the Russian groups have been putting out really good competitions. Like PH Days has been great for the past several years. So I'm super excited to see how this thing works out. I'm also excited to see how this works out. And especially since I wasn't able to play basically anything at all for Poly CTF this past weekend, getting back into playing some CTF this weekend sounds like a lot of fun. So that's super unfortunate that you're not going to be able to play. I know all too much about the traveling and trying to play CTF on a laptop while you're traveling. I got used to playing on a laptop, but it's definitely a relatively usable laptop. The one that I use is it's a modern MSI laptop. I got last September. I would say it's worth looking into the Bash and Ubuntu stuff on Windows, especially with Hyper-V. Like, I've been really happy with the way that using Bash and Ubuntu to SSH into a locally running Hyper-V Ubuntu VM ends up working. That's the way I've been doing all these streams for a couple months now, and it's worked out pretty well. Might be worth looking into if you really want to scratch the CTF itch. So, I think it's about all that I have for today. Didn't make quite as much progress as I would have liked, but we've got stuff running again. Hopefully on Wednesday we're going to have a bunch more crashes to look at. Yeah, should be good. Hopefully things will go well, and at least on Wednesday we'll have some more stuff to look at. Ooh, a 32-bit Windows machine. That could be rough. And I'm hoping that Wednesday we're going to take a look at a whole bunch of crashes, hopefully get a little bit better of an idea of where we stand with this stuff. And then on Monday, hopefully we're going to get back to some of the CTF discussion. Because hopefully there's going to be a ton of interesting challenges to talk about from these two competitions. So thanks everybody for tuning in this week. It's a little unfortunate we didn't get a little bit more progress, but we're getting someplace with it at least, and at least hopefully poking at the Python GDB stuff was interesting to people. It's something that I always remember it's a thing, and every time I want to do it, like, it's just complicated enough that I don't do it a lot, and when I do, I always have to look it all up and stumble over myself, as you clearly saw, trying to remember how to do it properly. So hopefully people who watch that learned a little bit and are able to make more use out of the GDB Python in the future. So thanks everybody. Thanks again everybody for tuning in. And if you have any questions or comments, feel free to message me on the Twitters or leave a comment here. Try and check both those pretty regularly. And other than that, I will see everybody on Wednesday. Bye everybody.